Hello to all my young friends who are studying in intermediate and they are watching this video. Friends, today we are going to start new subject. I hope that some of you must have guessed it correctly. Yes, we are going to start physics today. Now, one important thing which I'd like to tell you that in my earlier uploads, the video duration was half an hour to 45 minutes, 50 minutes. Now I am going to upload the full video of a topic. So the duration is going to exceed even 2 hours. However, you should not face any problem in searching for any topic of that particular chapter. Hence, I'll put all the details along with the links in description box. The video will have theoretical part as well as questions on each concepts. In our previous videos, we had covered calculus from mathematics. The reason for covering calculus was that many people find it very difficult. Hence, I thought it is better to start with a subject which many people find it difficult. And the next reason was that calculus has a lot of application in physics. Owing to this, many people find physics difficult. So, if you have not seen my videos, please do watch them. Calculus Made Easy series is there on my site. Just go to the playlist. You can watch it in Hindi or English. Even the people who intend to write NEET, for them also, calculus is important. You don't have to go into details and questions part of that, but definitely the concept part is important for them also. So at least study the concept part. We are going to start physics with mechanics. Mechanics is the a very important topic of physics. In fact, physics starts with mechanics. Of course, there are one or two more chapters before that. Introductory, you can say, and errors and approximations, and units and measurements. However, since they are quite easy, so I have kept them for future. I'll be posting videos on those topics also, but after some time. So we are going to start with mechanics. Now mechanics, as I told you, is very important, and the reason is a lot of concepts are involved in physics. Apart from you know uh, things which are abstract in nature, there are a lot of visualizations. You have to visualize things which normally you don't do in mathematics. Of course, in certain portion where 3D concepts are involved, you visualize things, but generally mathematics is more of abstract in nature, but physics is not like that. Here, apart from concepts, you require to visualize things, understand them very properly. That is one of the reason people find physics very difficult. Now let's see what we are going to cover in mechanics. We'll start with scalar and vector quantities and motion in a straight line, motion in a plane, Newton's laws of motion, friction, uniform circular motion, work, power and energy, center of mass, rotational motion, and gravitation. Now, many people find mechanics as a whole very difficult. So, my endeavor will be to present concepts in a very easy and lucid manner so that you are able to understand them, grasp them easily, and also visualize the things which is required in understanding concept by the use of suitable animations which I use from time to time in my videos, because they help you in understanding the concept properly. So please pay attention and try to grasp as much as possible. Now, if you are able to understand whatever I am going to discuss, I can guarantee you, you will score well, do well in your intermediate exams, and also this is going to be base for your NEET exam. In fact, NEET physics will be more or less covered with that, and also it will be a very good base for IIT-JEE, as I am going to cover a lot of questions from IIT-JEE also. Apart from that, some good questions I'm going to cover in each and every video. So please use this opportunity and have a good command on physics. Now we'll start with scalar and vector quantities. That will be our first topic in mechanics. And the reason is, as mechanics is very important in physics, scalar and vector quantities is extremely important not only for mechanics, but apart from mechanics, concepts are involved in many other chapters of physics also. And in mechanics, you will find their concepts, discussed and applied in most of the chapters. So that is very important. That is why I thought to start with scalar and vector quantities. Apart from this, one more important thing is that scalar and vector quantities are also covered in mathematics. So from concept part, I'll be covering more or less what all is required for mathematics. Definitely we'll be having some questions also. So here, if you study this topic properly, you will be covering your mathematics portion also. Of course, you have to do some questions there, so that you can do it. But in the same time, you will be covering two topics, one for physics, one for mathematics. So let us start with scalar and vector quantities. So let's start with the basic definitions. I'll start with basic definition and try to cover each and everything, uh, so that we don't miss anything in between. For the people who know some portion of it, it's going to be a revision, and for the people who don't know about this topic, it's going to be a thorough coverage of each and every concept. Now, what is a scalar quantity? Scalar quantity is that quantity which has only magnitude. And what is the example of that? Mass, time, temperature, volume, distance, speed. Why speed? Because speed is equal to distance upon time. Speed is defined as distance upon time. Since distance is a scalar, so speed is also a scalar, because distance and time both are scalars. Now, what is peculiarity about this scalar quantity? Summation of these scalar quantity can be done by ordinary algebra. What do we mean by that? Take mass. You have 2 kg plus 5 kg. Will make it 7 kg. Or 1 liter plus 4 liter is equal to 5 liter. Or 3 kilometer plus 6 kilometer is equal to 9 kilometer. That is, we can just sum them by ordinary algebra. On the contrary, vector quantity is that quantity which has magnitude as well as direction. So you can see, in addition to magnitude, this has one thing which is called direction. Now what is the example? Displacement. Now why are we telling that displacement is a vector quantity? Because direction is involved. You may ask why. Now let me explain it to you. In fact, we will be discussing this in other topics also. For example, this is the position of any particular body. It moves in this direction, say 10 units, meter, centimeter, kilometer, whatever it is. So now distance is equal to 10 and displacement, that is also equal to 10. Means it is displaced by 10 units. But if it returns back again, it comes back to this position and it travels 8 units. Now the distance is equal to 10 plus 8, 18. But displacement is only this 2 units. And if it comes back to P, then the displacement is 0, but the distance is 10 into 2, that is 20, if it follows this path which I have drawn here for going and coming. So that means displacement requires direction. Velocity. Now since velocity is equal to displacement upon time, so since displacement is a vector, velocity is also a vector. Just notice the difference. Speed is a scalar, velocity is a vector. Force, momentum, torque, electric field. Now we will be discussing more about these in the coming chapters as we proceed. Now here the summation cannot be done by ordinary algebra. For scalars, we can do the summation by ordinary algebra, but here we cannot do it. Why? For example, take an example of force. It's a vector. You have 2 Newton in this direction, and in the same direction you have 4 Newton. So if you add both these, it will become 6 Newton. Now, if you have 2 Newton in this direction and 4 Newton in this direction, so now the resultant will be 2 Newton in this direction. If you have 2 Newton in this direction and 2 Newton in this direction, the resultant will be 0. Now if you have, say, some 3 Newton in this direction and 2 Newton in this direction, the resultant will be different, which we will be discussing. That means here it is very important to know what is the direction, because result depends upon their direction. Let's talk about classification. They are classified as polar and axial vector. Now what is a polar vector? It has a well-defined starting point, described translation motion, confined along a straight line, displacement, velocity. For example, if you have any particle here, so this is the starting point and it moves in this direction, so this is the displacement. So that is confined along a straight line. Axial vector. Now physical quantity which is represented by this axial vector is not confined along a straight line. They describe rotational motion and act along the axis of rotation. What is the example? Angular velocity, torque. They are also known as pseudo vector. Pseudo basically we say false. So they are also called pseudo vector. Now we'll be studying angular velocity and torque and other things in the coming chapters, but let me give you some idea about it. Now, for example, there is a disk which is rotating about its axis. This is the axis of disk and it is rotating like this. So angular velocity omega is defined along the axis of rotation, which is a axial vector. Now zero vector. What is a zero vector? Which does not have any magnitude, no magnitude and no specific direction. Now it may look a bit odd. If we say no magnitude, it may be okay. But if we are telling there is no specific direction, that looks a bit strange because vector has to have direction. But what is a zero vector? If A and B, two vectors, we write them like this. That means vector A. We put an arrow on above A. They are equal. Then their difference A minus B is defined as a zero or null vector. So A minus B, if A and B both are vector, it is defined as a zero vector. Now properties of zero vector. If we add zero vector in any vector, it remains same. If we multiply zero vector by any scalar quantity, it will become zero vector only. And if we multiply 0 by any vector, it will result into 0 vector. Now just read this, that 0 vector does not fit into our description of vector because, as I discussed, it doesn't have any specific direction, but it is needed due to the following reason. What are the reasons? Now if I ask you, if A and B vectors are equal, then what is A vector minus B vector? Or what is the displacement vector of a stationary object? Or if anything is moving with a constant velocity, then what is its acceleration vector? So the answer to above is zero vector. So here a very interesting thing I'd like to mention, that just as 0 is important in real number of operations, concept of 0 is very important is vector operations, concept of zero vector. And you know, 0, the concept of 0, you must have studied in your previous classes. It was very important concept which was given by Indians. Now since a vector has both magnitude as well as direction, it is represented by an arrow like this. Its direction is same as that of quantity. If you are representing any vector quantity, so whatever is the direction of that vector quantity, the arrow will have the same direction and the length of the arrow will be proportional to quantity's magnitude. Suppose I want to represent 5 Newton. Now 5 Newton force, it's a vector quantity. Now if I take a scale such that 1 centimeter represents 1 Newton. So I will draw an arrow of say 5 centimeter. So this length is proportional to the magnitude here. Suppose my scale is 1 Newton is represented by half a centimeter. So my arrow's length is going to be 2.5 centimeter. Now, scale depends upon us, how we choose it. But the length is proportional to quantity's magnitude. And we write generally like this. Suppose we want to write a vector, we'll represent it by an arrow, a vector, and we'll write like this, or even we'll write like this, both ways. Now this portion which is in encircled, this is called head, terminal or final point of the vector, and this point is called tail, initial point of the vector. Now vector is defined by its direction and its magnitude, but not by its position in space. It's a very important concept. Now what do we mean by that? That means if a vector is shifted parallel to itself without changing its magnitude and direction, then it does not change. It remains the same. That means, suppose if we have this vector, we shift it parallel like this, or like this, or like this, or like this. In all these cases, the direction and magnitude are same. So it doesn't matter. The vector remains same. It does not change. It's very important. And this thing we'll be using it now. You'll see. Now equality of vectors. Two vectors are equal if and only if. This symbol means if and only if. I think you must be familiar with this. If and only if they have the same magnitude and direction. What do we mean by that? Suppose we have two vectors like this, A vector and B vector. Here you can see the size of this arrow is same and direction. That means A is equal to B. The magnitude and direction of A and B are equal. But if we have another vector D like this, here the magnitude of D is equal to A and B, but its direction is same. So we'll say this is not equal to D vector. One peculiar case, suppose you have a E vector like this and another vector parallel to this but has a reverse direction. So E and F are equal in magnitude but they have opposite direction. So we'll write E vector is equal to minus F vector, or F vector is equal to minus E vector. Now addition of two vectors. Now the question is how to add two vectors. We have discussed that we cannot add them by ordinary algebra because they have magnitude as well as direction. Suppose this is one vector and this is another vector, A and B, and we want to add A and B. Now how to do that? We'll draw A and we'll shift B parallel to itself here such that the tail of B coincides with head of A like this. Now if we join this point and this point, we will get the resultant R, which is the sum of A vector and B vector. So A vector plus B vector is equal to R vector. So if you want to add two vectors, suppose P and there is another vector Q, just put the tail of Q with head of P and then join this point and this point. So you will get the resultant. Now here we have started with A and added B. You can also start with B and add A to that. Now this will be the resultant R, which again is equal to same, which is the same as here. So B plus A is also equal to the same vector. That means A plus B is equal to B plus A. A vector plus B vector is equal to B vector plus A vector. Now this property is called commutative. That means addition of vectors is commutative. Now commutative, what do we mean by that? See, addition is commutative. That means 5 plus 4 is equal to 9, or if we write 4 plus 5, that is also equal to 9. But subtraction is not commutative. 5 minus 4 is equal to 1, but 4 minus 5 is equal to minus 1. So subtraction is not commutative. But if you see the numbers, addition of numbers is commutative. So addition of vectors is also commutative. So this method of addition is called triangle law of vector addition. Triangle law of addition. Why do we call it triangle law of addition? Because we are adding A and B vectors and we are getting a resultant like this A plus B vector. So this is a triangle. That is why it is called triangle law of vector addition. We can also add them using parallelogram law of vector addition. See, in our previous case, what we have done, we have taken one vector and in its head we have put the tail of the second vector B. Okay, we can write like this also. Please don't get confused if I have made the arrow mark here. Okay. Now instead of connecting tail of one vector and head of one vector, we connect the tails of both the vectors. So this is A vector and this is B vector. If I connect their tails at one place, then what I'll do is I'll draw a line parallel to B vector from here like this and like this. And now if theta is the angle between these two vectors. Now this diagonal vector will represent the resultant. You can see it very well because if you shift A vector to this place, this will become your A vector, right? So the diagonal of this parallelogram represent the resultant A plus B. Now you can see the resultant varies with the angle between A vector and B vector. Now if the angle theta is 0, the direction of A and B will be same. So they will be just added, and if theta is 180, they will be in opposite direction. So you will take the difference. That means subtract the smaller one from bigger one. So if theta is equal to 0, the resultant is maximum. We just add their magnitudes. Say for example, you have 2 Newton and 5 Newton. So this becomes 7 Newton. So what you have done? You have added the magnitude. Here the magnitude is 2, here it is 5, then 7, and this is the direction. If theta is 180, the resultant is minimum, either A minus B or B minus A. Now, this is the way of writing the magnitude like this. We write, this means mod, magnitude.